You use Pythagoras theorem, cosine rule, the cosine rule. Yeah, same thing. It works out. So you can do this two ways, okay? So you're after b to d, aren't you? B to d is x. What type of triangle is this? Is it right angled? So you can use Pythagoras theorem. So you can use x squared equals 12 squared plus 9 squared. And I think when you add that together, you get 225. You square root your answer, you get 50. You square root 225, you get an answer of 15. It's also possible to use the cosine rule. Somebody used the cosine rule over there, which also works. You would have got x squared equals 12 squared plus 9 squared minus 2 times 12 times 9 cos 0. Or sorry, cos 90. And you find out it's actually the exact same answer. 225. And then you square root the answer and you get 15. Sorry, you get 15. You can't do the sine rule. The sine rule won't work. Why didn't we could use Pythagoras theorem because it's a right angle triangle and we knew two of the sides, didn't we? You cool with that? All right. So, okay, so we got the length of BD. It's 15. What does it want next from us, guys? It wants the area of both triangles. Would you agree with that? So we'll call this area A and area, actually no, A is already in use. We'll call this area X and area Y. What formula are you meant to write down when you see area of a triangle? We've done it once today already on question A. Anybody remember? A half AB C. Okay. Now let's start off with X. What are the two sides we're going to use? We're going to use 9 and 12, yeah? What's the angle in between them? Done. Throw that into the calculator. What you get? Huh? 54. Okay. And then this one here. What two sides can we use? Fifteen and 14. What's the angle in between? Sine 63. Throw that into the calculator and let me know what you get. .93. We go. Okay. It wants the area of both of them added together though, because it wants the area of the full object. It wants A, B, C, D, so it wants A to B. Did you multiply them? And I'll just add them. Yeah. What units? Centimeters squared. The goal of the question is to find this red line here, isn't it? But the problem with that red line is there's no information in the small triangle. So you have to go over here. And the first thing I would do is I try and get this red angle here. What do you think that red angle is? It has to add up to 180. Is it not 106, lads? 106, yeah? Because it has to add up to 180 in total. So it's 106, okay? Now once I get access to that angle, I can then get access to the blue angle. What do you think the blue one is? 180 take away 106 take away 43. You got 31. Okay. Now, What's the most important side in this whole system? I think this green line here is very important. Can anybody tell me why the green line is very important? Because it transfers information to the other triangle. Then if we can figure out what this is, we can figure out what the other triangle is. So I think we could try a sine rule here, could we? Who's x fighting? Sine 43, yeah? And who's 10 fighting? 10's looking at the 31. Now you just have to figure out what x is. Okay? Alright, so multiply it up. And everybody in the class is telling me that's 13.2. Okay? Is 13.2 the height of the castle though? No, it's not. Is the height of the castle bigger or shorter than 13.2, do you reckon? Hmm. So 13.2, yeah? And we believe the red one's shorter, don't we? Okay. Now looking at the triangle on the right, what rule do you think I can use here? Should I use Pythagoras' theorem? No. I could use SOHCAHTOA, but I think we might try the sin rule again, will we? Okay, let's see who's fighting who then. I'm just going to call it H. 12.7 is shorter than 13.2, so that looks good. So who's fighting? Who's H fighting? Yeah. Who's 13.2 up against? Who's who's 13.2 up against? 90. And then what you gonna do with the sine 74 on the bottom? Bring it up, put it up beside the 13. What do we get, guys? 12.7. We'll just confirm that answer for somebody else and then we're good to go. 12.7.